Okay, so today we're going to look at calculus, the second problem from the calculus review packet. Just a quick note, I did a live stream at 10 a.m. It started off a little rocky, some technical issues, but I had some people in the live stream, and after we got past those technical issues, it actually went really well. I mean, this is coming from me, I don't know, maybe from the students, it wasn't so great. Um, but I mean, I don't know. Maybe you'd prefer to watch me play video games. But anyway, the point being is I thought it went pretty well. They asked some good questions and things like that, some really good clarifying questions, which of course in this video, since I'm just doing a video, you won't be able to ask. So I strongly suggest that you take advantage of the live streams because again, they were, according to the students who were there, they thought it was very helpful to them to ask those questions, to do the clarifications, things like that. Um, Anyway, so I'm gonna continue here and let's see what we got here. So I'm going to let's see here. Oh, just a couple notes. If you do end up getting interested in joining the live stream, I will be doing another live stream tomorrow at 10 a.m. It's going to be covering problem 4 from the review packet. I will put information about it on my website. Also, there will be information on my Discord channel. There's a link to there's an invite link on the website to the Discord channel. Feel free to join it. That's where people are asking questions, and I have all sorts of stuff set up there, links and things like that to previous videos and things like that. So a good place to join. Anyway, let us move on here and do question number 2. So the graph of the function f, as you guys can see, is shown below. So they're talking about this graph and they're saying it's made of some line segments and a circle. Now this is the important part right here. This right here is important because it tells us what we're looking at. So they told us the graph of f is the graph that's shown, but g equals the definite integral of that graph. So in other words, and again, this is important, the graph that we're looking at right now is g prime of x because we are told that it equals f. Okay, so we are looking at a derivative function. So we are looking at a velocity function. Remember, we talked about the other day. Anytime they give you a function, any kind of like a function, a graph, or a table, you have to ask yourself, is it a position function, velocity function, or acceleration function? That should be the very first thing that you do. Because if you don't do that, then the rest of the problem is going to go very poorly for you. Okay, so we are looking at a velocity function, a derivative. So let's start off. We're going to go find g of 0. So according to this part right here, if I want to go find g of 0, then g of 0 is going to be the definite integral from -3 to 0 of f of t dt. That's just how it's defined. Okay, well, let's see what that equals. So that's going to be equal to, so let's look at the graph. That's going to be the stuff underneath the graph, all this stuff right here. It's going to be equal to that trapezoid because again, the definite integral represents the area, either the positive or negative area um, from the curve to the x-axis. So in this case, it equals that trapezoid. So all we're going to do is we're going to find the area of that trapezoid geometrically. And the area of a trapezoid is 1/2 the base times the height. So I'm going to say that this right here, we'll call it base 1. This height right here, base 2. And then this distance between, that's my height. So it's going to be equal to 1/2 base 1, which is 2, plus base 2, which is 1, times the height, which is 3. Again, it's the area of a trapezoid equals 1/2 the base time, the average of the bases times the height. So in other words, 9/2. Okay, next we're asked to find g prime of 0. So g prime of x is going to be equal to the derivative of this. Now, they didn't ask me to justify it, so if I had been asked to justify it, then this work that I'm doing right here would be really useful. But they did not ask that, so this part is just really for you guys. So this equals the derivative of this, which in this case is going to be equal to that. So they want to know specifically what is g prime of 0. Well, that's going to be f of 0. And f of 0, looking at the graph, is this point right here. So it is 1. Okay, let's move on to question B. Find all the values of x on the open interval from -5 to 4, where g obtains a relative maximum. Justify your answer. So in this case, this is very similar to yesterday. So what I'm going to do is, first, I want to remind you, where do you find relatives? How do we find relative minimums or maximums? We find relatives or minimum maximums by taking the derivative of the function. So in other words, looking at g prime and determining where it goes from, we're looking at g prime and determining where it goes from positive to negative. So what do we normally do? We make a sign chart. So that's what I'm going to start with. I'm going to make a sign chart for g prime, which equals f. Now, I want to emphasize, I told you guys this yesterday, they don't look at sign charts. So this is a tool for me. It is useful for me. It is useful for you, but they're not going to read it. Okay, so don't make a sign. Don't let your justification be your sign chart, because that's just wrong. Okay, so we're going to find relative minimums or maximums occur at critical values, and critical values occur where the derivative equals 0 or it's undefined. They did not tell us any instances where this function is undefined, so I'm just going to look for my critical values where the derivative equals 0. So the derivative equals 0 here, it equals 0 here, and it equals 0 here. So my critical values are at x equals -4, x equals 0, and x equals, what is that, 1, 2, 3. Okay, those are my critical values. Next, I want to go make a sign chart. So remember, what do? I look to the left and I look to the right of each critical value. So let's look to the left of -4. To the left of -4, the graph lies below the x-axis, which means all those values are negative. So to the left of -4, all the values are negative. Notice to the right of -4, all the values are positive. So in other words, we have a relative minimum there. Okay, let's keep on going. Let's look at x equals 0. So to the left of x equals 0, we are already aware of that the graph lies above the x-axis, so it's positive. To the right of x equals 0, notice it's still positive, right? What does that tell us? That means there's some sort of stall here. So if we were graphing this, we'd make sure the derivative equals 0 at that point, because there's some sort of stall. And then finally at 3, which is still from here, to the left of 3, it's positive, as we said, but to the right of 3, it's now below the x-axis, so it's negative. So that means it goes from positive to negative, so there is a relative maximum there. So answering the question asked, what was the question? Find the relative maximum and then justify. So my answer is going to be, there is a relative max at x equals 3. Why? Because g prime equals f. So I'm saying, here's how I know, I'm talking about g right now. How do I know these? They're asking questions about g. So how do I know? I say, look, when I want to look at g, I'm gonna look at the derivative of g, and the derivative of g equals f. Okay, so I'm saying now I'm looking at f. So I'm saying we're talking about g, but I'm pointing to f to do my justification. So f changes from positive to negative at that point. Okay? So that's all we need. In terms of a justification, all they need, there's two things you need on this. This would probably be a 2-point question. So point 1 would be given for where's the relative maximum at? What's the x-coordinate? The x-coordinate is x equals 3. Then the second, I just want to make sure I've actually answered that question. Yes, I did. Then the second part is justify. My justification, this is it. That's my justification. I said, look, I'm looking at f, and then it's changing from positive to, f is changing from positive to negative at that point. Okay, let's move on to C. I am going to have to erase things because I need to look at my graph. So, my earphones are dying here, so I'm hoping that the sound quality remains okay. because this will make me sad if it does not. Okay, let's go to C. So it says find the absolute minimum value of G on the closed interval. So let's go and do that. What is going on here? Did I do that? Okay, so absolute minimums, absolute maximums. We've talked about this before. Absolute minimums and maximums occur at either endpoints or critical values. So let's go through and look at our possible values. So there's our endpoints. So we need to know what is G of -5. That's an endpoint. We need to know what is G of 4, because that's the other endpoint. And then I need to know my critical values. And we had a few different critical values. Now, I'm going to kind of just write these three critical values down that we found before. The critical values were G equals -4, G equals 1, and G equals 3. But I want to remind you, I don't need to look at all of these. And the reason I say that is when we did G equals 3, right? We said there was a maximum there. Well, they're asking for a minimum. So guess what? I'm not going to even consider it. So if you don't mind, I'm going to erase it. Don't need G equals 3. Also, when G equaled 1, there was a stall point. That's neither a minimum nor a maximum. So again, I can ignore that. There was, as we saw in our sign chart, there was a relative minimum at -4. So that needs to be considered. So let's see what we can do here. Let's go find our values. So I'm going to go find my values just like I did before. This is the integral from -3 to -5 of f of t dt. And those limits of integration, I'd like to switch them so they go from least to greatest. So that becomes the negative of -5 to -3 of f of t dt. So let's think about what that is. That is the area underneath the curve, this stuff, right? That is the area underneath the curve. Well, I shouldn't say underneath. From the curve to the x-axis, from -5 to -3. So it's the purple highlighted stuff. You probably noticed those are two triangles, and those two triangles are equal. One of them is below the x-axis, so it is negative, and one of them is above the x-axis, so it's positive. So those two values are going to cancel each other out, and we are going to get 0. Next. Okay, so now I'm going to go find G of 4. So let's go find G of 4. Let me erase what I did here. Sorry, I just got a little distracted. Somebody asked a question in Discord. I will get to them, though. I can't do it this second because I want to keep this video relatively short. So we're going to go from -3 to to +4, excuse me. So we're going to go from that to -3 to 4 of f of t dt. So again, that's already actually set up. So let's see, that is this stuff all the way to here. Okay, so I'm looking at all that purple stuff. So I'm going to break that up into sections here. So let's go and do that. So section 1 is this part. Now we actually found this originally. If you look at when we found G of 0, we already found that. So we already know that area of that trapezoid, and I believe the area of that trapezoid was 9/2. So if you don't mind, I'm just going to put in 9/2 because we already found the area of the trapezoid. Next, I'm going to go and find this part right here. So I want you to notice that we did one like this the other day. What I'm going to do is I'm going to do something very similar to what I did the other day. I'm going to find the area of this rectangle, this red rectangle right here, and I'm going to subtract the semicircle, which is all air, and that will give me the purple stuff. So in this case, the area of I'm going to add to my 9/2 the area that I just indicated. So it is the rectangle, which is a base of 2, a height of 1, minus the area of the semicircle, which is 1/2 pi r squared. R is 1, so 1 squared. Okay, got that? The last part that I need to do is I need to go and find these two pieces. Notice those are opposites of each other, so that's going to be equal to 0. So I'm not going to evaluate this. Yes, this is a number, and I might need to look at it. But for right now, I'm going to recognize 9/2. This is like maybe, so 9/2 is 4.5 plus 2 is 6 plus this number, whatever that is, like half a pi. So 6, so maybe somewhere between like 4 and 5-ish. I might need to be a little more specific later on, but let's just check. I know it's like 4 or 5-ish, and I'm just going to keep that in my mind for right now. Let's go find g of -4. So g of -4 is going to be the integral from -3 to 4 of f of t dt, which again, -3 to -4. So I'm going to flip those limits of integration, and it's going to go from -4 to -3 of f of t dt. And notice, in this case, we are just talking about this triangle right here, right? We're just talking about that triangle right here. So this equals the negative, and that triangle is going to be base times height. So it is 1/2, 1 times, excuse me, 1/2 times 2. Okay, so let's just make sure. Did I just mess it up? I just want to make sure I'm I did mess it up. Let me try that again. I indicated the wrong triangle. So let me fix that. I just realized that. I knew that because I knew what the answer was. So I'm actually talking about this triangle right here, right? This is the triangle that goes from -4 to 3. So my apologies. So in this case, it's going to be equal to the negative of that area, and that area is 1/2 the base, which is 1, times the height, which is 2. So that equals -1. So notice, in summary, g of -5 was 0. G of 4 was some positive value. G of -4 is -1. So that is my minimum. So what did they ask here? They asked us to find our values. So our absolute minimum is g of -4, which equals -1. Now, notice they did ask for justification. All the stuff that I did above, all this stuff, that's my justification. That's it. I don't need to go any further. I don't need to put into words or anything. If I have that, that's my justification. Okay? Let's move on to D. Find all the values of x in the open interval from -5 to 4 at which the graph has a point of inflection. Okay, we are looking at inflection points at this point. So reminder, inflection points, where do we look at inflection points? We look at the second derivative, okay? Now they're not asking for an explanation here, so we're looking at just the second derivative. So actually I'm going to erase this stuff so I have room. That's not how I erase. Let's erase this. So let's go and do it. Let's go find those inflection points. So remember, I'm looking at second derivative. So in other words, I'm looking at the derivative of this. So in other words, what they're really asking for is if I'm looking at the derivative of the graph, so I'm looking at this graph right here, I'm looking at its derivative, what I'm really looking at is the slopes of the tangent lines. And what I want to know, inflection points occur when the derivative of the original graph changes from increasing to decreasing, right? So in other words, where the slope of those tangent lines change from increasing to decreasing, so or positive to negative, I should say, when they change from positive to negative. So notice, from -5 to -3, the slopes of the tangent lines to my graph are positive. From -3 all the way to 0, it's negative. What does that mean? At x equals -3, there's an inflection point. Then we keep on going. Let's see. So from -3 all the way, actually all the way to 1, right? All those slopes of the tangent lines are negative. But what happens at x equals 1? Well, at x equals 1, they were negative to the left, but now to the right, all the slopes of the tangent lines are positive. So at x equals 1, there's another inflection point. And then finally, at 2, again, it changes, right? It was all the inflection points were all the slopes of the tangent lines were positive, but at x equals 2, at x to the right of 2, they're all negative again. So my last inflection point would be at 2. Now, if they asked to justify, which they did not, I'm not going to do this for every single one, but let's say I wanted to justify that x equals -3 was an inflection point. What I would say is I would say g, um, let's see, I'm trying to put this in I want to make sure I don't mess this up. So I'm going to say g double prime of x, which equals f prime of x, changes at x equals -3, changes from increasing to decreasing. And so therefore, there's an inflection point at -3. Now I want to emphasize the language, the increasing, decreasing. I am talking about the change in I'm talking about the derivative now. So when I'm using the word increasing, decreasing, I'm using rate of change words. I'm using derivative words. So I'm saying that f prime is increasing. What is I'm saying? I'm saying f prime is increasing, so the derivative of f prime, right? Derivative of f prime is positive. So f double prime is positive, f double prime is negative. So I'm using the increasing, decreasing words to emphasize that I'm taking the derivative of f prime. Anyway, hopefully that was useful, and that's the video.